So in the previous lecture, we talked about oxidations of olefins generally, where we said that one of the ways in which oxygen is introduced into the double bond of alkenes, which are the olefin, is by the oxidation of polycyclic olefins. Now, that will be the purpose, or let's say the objective of this lecture, to talk about the oxidation of polycyclic olefin, the oxidizing agent that is used, and then the product of the reaction. Now, at the end of this lecture, what are you expected to know? You're expected to know how to determine, or you are expected to determine the oxidizing agent used and the product of oxidations of polycyclic olefins. Now, let us go deeply into actually analyzing the concept for this lecture. The question is, what are polycyclic olefins? Now, polycyclic olefins are compounds like cyclohexene, right? They are compounds like cyclooctane. They are compounds like cyclopentane. These are cyclic compounds that actually have a double bond in them. For instance, cyclohexene will be the main focus of this lecture, since that is the one that is in our material and that was the one that was actually discussed. So we have this as cyclohexene, which has a double bond here like this. This is benzene structure. Cyclohexene has this representation. Now, polycyclic olefins such as cyclohexene can be oxidized using chromium trioxide. Now, we discussed chromium trioxide as one of the oxidizing agents initially, right? We said chromium trioxide is something like this, which we said the commercial name for it is sodium heptaosodichromate, right? Now, chromium trioxide plus acetic acid plus H2O to form a varieties of products. Now, this method is not a good synthetic tool for actually oxidizing alkane. The reason because it forms different varieties of product. Are you getting it? So if you need the yield of one product, let's say you need a particular product in a higher yield, you will not be able to get it. Reason being that when you use this chromium trioxide and acetic acid plus H2O to oxidize these polycyclic olefins, it forms varieties of product. That means it forms more than one product. And in a situation where you have only, let's say only this one giving rise to product A, product B, let's say product A, product B, product C, product D, product E, product F. Only this one giving birth to this, and a situation where only this one gives rise to A. Now, or let's say A and B. What can you actually infer from here? You can infer that these ones, they will be in small proportions, or let's say in small amount. Like this one may be 20%, 30, 20 gram, 30, let's just assume 5 gram like that. Why this one may be just 70 and 80 gram like that, or 80% yield. Is that understood? So because it leads to the formation of a varieties of products, it is not a good synthetic tool for the preparation of, or for the oxidations of alkenes. The question is, what are some of these products that are formed from the oxidation of polycyclic olefins? Now, the products that are formed are alpha, beta, unsaturated carbonyl compound. Let's say unsaturated ketones. The other product that is formed is, you can form adipic acid. Now, adipic acid is formed in a way that the ring of the cyclo or polycyclic olefin is broken down. So this is the only product that is formed due to the breakdown of the polycyclic olefin ring, adipic acid. Are you getting it? Now, adipic acid is a dicarboxylic acid. Let's take note of that. It is a dicarboxylic acid. When you say something is dicarboxylic, what does that mean? It means it has two carboxylic acid group. Now, the general formula of adipic acid is something like this. You have OOC, right? Then you have CH2, then you have 4, and then you have COOH. Are you getting it? This is adipic acid, and this is the general formula. Like I said, it is a dicarboxylic acid. The reason why I said it is dicarboxylic is because it contains, this is one carboxylic acid group here, and this is another carboxylic acid group. So how many carboxylic acid groups are present here? Of course, we have 2 carboxylic acid groups that are present here. Now, another product that is formed is cyclohexanone. Cyclohexanone. And then lastly, the last product that we are going to look at is cyclohexandiols. Cyclohexandiols, or you can say cyclohexane 1,2-diol. Now, all these products will be formed from the decarboxylation, or from the oxidation of polycyclic olefins. All these products will be formed from the oxidations of polycyclic olefins, especially cyclohexane. As a case study, we are using cyclohexane here as a case study. It does not mean that if you use cyclooctane, you will form the same product. If you use cyclooctane, you are going to form products that are analogous to that of cyclohexane. So if you use cyclooctane, for instance, instead of it to be forming cyclohexanone, you'll be forming maybe cyclooctanone. Are you getting it now? Instead of you using let's say instead of you to be getting cyclohexanediol, you'll be having cyclooctadiol, etc. Do you get it now? But these are the products that are formed from the oxidation of polycyclic olefins. Like I said, olefins are also called the alkenes. Products that are formed are alpha-beta unsaturated ketones, adipic acid, which is a dicarboxylic acid. Then we have the cyclohexanone, then we have the cyclohexanediol. Now we said that of adipic acid is formed from the cleavage of the bond. That means the product that is formed as a result of the bond, or let's say the ring, is broken down. So this is the only product that is formed due to cleavage of the ring structure of the polycyclic olefin. Now, taking this one into cognizance, if you oxidize this with chromium trioxide and acetic acid, what is the product that we are expected to form, followed by hydration with water at a temperature of 25 degrees Celsius? Now we are going to form an alpha-beta unsaturated ketone, and that product is this. We are going to form, this is what we call alpha-beta unsaturated ketone. I know some of us, we are wondering, what is this guy talking about, like alpha-beta unsaturated? Now this is like the group carrying the functional group. Here, if you look at this structure very well, this is the group carrying the functional group. This is the ketone functional group, right? Now this group here is called the alpha group. Why this group here is called the what? Beta group. So we call it alpha beta unsaturated. Are you getting it now? Alpha beta unsaturated, because the double bond is between the alpha and then the beta carbon. So we call it the alpha beta unsaturated ketone. Look at it. Alpha beta double bond unsaturated ketone, major functional group there. And then the name of this compound is, we can call it 2-cyclohexanone. Right? 2-cyclohexanone. Reason being that if you count this now, forget about the alpha beta unsaturated. Now if you count this, here will be number 1 from organic nomenclature. We are told that if you have a compound like this, the functional group, where the functional group is attached, is number 1. Here will be number 2, and here will be number 3. So at what position is the alkene or the unsaturation? At what position did it take place? At position number 2. So you call this 2-cyclohexanone. Are you getting it now? Hexane, 2-cyclohexane. 2-cyclohexane means at position number 2 there is a double bond, then hexanone. Reason because of this own functional group. So that is everything you need to know about the oxidation of polycyclic olefin. Now this will also give plus adipic acid. I told you that adipic acid is something like this: HOOC CH2 4COOH. Now this is adipic acid. Right? Adipic acid. We said this one is formed from the cleavage of the ring. So I've emphasized this enough. So these are just two products that will be formed due to the oxidation of this polycyclic olefin by chromium trioxide in acetic acid, followed by hydration at a temperature of 25 degrees Celsius. Now, all these things that you are writing here is not just all about cramming formulas. You should visualize them. Let's say you are in the laboratory and then you want to make these alpha beta unsaturated ketones. How do you make them? Now, first of all, you have, let's say, a cyclohexene given to you. You have sodium heptazodichromate, which is where you find your chromium trioxide. So if you put the chromium trioxide in acetic acid at 25 degrees Celsius with water, then the cyclohexane, that means you are going to get your 2-cyclohexenone, which is the desired product, or adipic acid. You know, chemistry, pharmacy generally is a practical oriented course, but the situation we find ourselves, we just have to try as much as possible to visualize these things, right? These are not rocket science. They are things that when you carry out the practical, you actually get what you desire. So that is the product of that reaction, and I believe that is everything that has to do with this. Now, like I said, that these are not just the only product that will be formed. You will also form cyclohexanone, cyclohexadione, and different other products, but these two are the major products that we are taking, since these ones are the ones that are well represented in our materials. Is that understood? So let us go straight to the next, or let's answer this question. It says, which of the following is a product of oxidation of cyclohexane with chromium trioxide in acetic acid with cleavage? Take note of this statement, with cleavage of the ring to form an open chain. Now, 2-cyclohexenone or hexanone, this is supposed to be hexenone, will not lead to the cleavage of, or will not lead to formation of open ring. The only one that leads to the formation of open ring is adipic acid. Look at it. When you say open ring, look at this ring here. It's not closed. It does not form a cyclic structure. So the only one that leads to cleavage for the formation of open ring is adipic acid. So cyclohexanone is wrong. Cyclohexadione is wrong. Correct answer is adipic acid. Quite an easy question, right? So that's basically everything you need to know about this lecture. Now, let us spy into what we have in our next lecture. In our next lecture, we are going to talk about the hydroxylation reactions of alkene.